In this lecture, I would like to discuss the raw data format of DC transfer function in LTspice and how to read the raw data using Python language. .tf is the syntax in LTspice to find the DC small signal transfer function of a voltage or current due to small variation of an independent source, such as voltage source or current source. We are looking at the small signal, not the large signal. The output is a dialog box that gives low frequency gain, input and output impedance of a circuit. The syntax is .tf followed by the voltage or current as the output. After that, that's the independent source. For example, .tf Vout, Vin means the DC gain of Vout due to the small variation in voltage Vin. This is an emitter follower using a NPN transistor. I will go to LTspice just in a minute. The syntax is .tf Vout Vin. TF means transfer function. Remember, we are looking at the small signal. The voltage gain A sub V will be Vout hat over Vin hat, which is about 1. The hat is the symbol of small signal variation. Now let's go to LTspice. Let's go to the folder for this lecture. Let's open the given schematic. This is an example of emitter follower. The input voltage is applied at the base of the NPN transistor. Output is at the emitter to the ground, across the resistor R1. Let's move the mouse over the syntax for transfer function, .tf. You can see the simulation command is DC transfer. It will find the DC small signal transfer function. Output is Vout. We are using name out here. The source is Vin. The voltage is 2 volt. This is the syntax. Now let's run the simulation. Once you run the simulation, the result will pop up. The transfer function is found as 0.98, which is approximately equals to 1. That means in AC small variation, Vout has the same variation in magnitude as Vin. The input impedance, if we look at the input side into the circuit, is 311 kilo ohm as impedance. If we look at the output impedance at Vout, the output impedance is as low as 17.8 ohm. Overall, this circuitry gives approximately unity gain in AC variation from input to output. It has high input impedance and a low output impedance. Let's close this simulation file. Now let's go to the local folder for this lecture. You can see there's 3 files are newly created. Let's open the notepad and double check the data. The first one is raw data. This is the raw data generated by the simulation. The plot name is transfer function. Flags are 0. The number of variables is 3. Number of points is just 1. There are 3 variables, namely transfer function, input impedance, and output impedance. This is the header file. Binary data will be read into Python in just a minute. Now let's open another one, .op.raw. This is the operating point regarding the transfer function simulation. Flags are 0. Number of variables is 9. Number of points is just 1 at time equals to 0 second. Here are all the variables regarding the circuitry in the DC solution, including all the voltage and current of each device. Binary data associated with voltage and current in variables are shown here as well, which will be later imported to Python. The last one is the log data. You can see this is the basic information about this simulation. Let's close the notepad and go back to the slide. This is the raw data format. Please remember that the raw data format for DC transfer function .tf and for DC operating point .op are the same. The source value is in 8-byte, followed by 4-byte variables such as variable 1, variable 2, and etc. .op.raw has the same data format as DC transfer function. Now let's move on to the demo. I will show you how to read .raw data and .op.raw data into Python IDE. Make sure you are in the correct directory for this lecture. Let's open the given Python code. You can see there are two cells. This is the first one. This is the second one. The first one is going to read .raw data into Python. The second cell will read .op.raw data into the Python. Please double check the input file name and make sure it's correct. Let's run the first cell. Variable Explorer has all the results as we defined here. The names of variables are inside the variable of name underline transfer function. Double click, you can see these three variable names: transfer function, input impedance, and output impedance. SD values are the DC transfer function data saved as the variable name DC underline transfer function. This is a list of 3 NumPy arrays. Each NumPy array just has one element, which is the simulation result. One more time, this is the transfer function. The second one is input impedance. The last one is the output impedance. Now let's move on to the second cell. Second cell will read the operating point in the raw data. And the name for the variables will be name underline OP. The values will be saved in DC underline OP. The same data is saved as SD2. Let's run this cell. First, let's check the names. All the names of DC operating points are given here, from V-in all the way down to current of V1. DC underline OP, that's the variable saved including all the data. So this is the data for all the DC operating point. For example, the first one is the input voltage at 2 volt. I have shown you how to import raw data and the .op.raw data into Python. That's all for this quick demo. This is the reference for this lecture. Thank you very much. See you soon.